Excellence, Kalaburgi. He is having more than he is having more than 23 years of teaching, research and administrative experiences. He has completed his undergraduate in Periyar Arts College, Kudalur, postgraduate in St. Xavier's College, Tirunelveli, and doctorate in Madurai Kamaraj University. Also, Sir received Junior Fellow Research Scholarship and Senior Fellow Research Scholarship in CSIR NET. He also received Hindi Certificate course and Sanskrit spoken course also. He is also having a life membership in IMS, ISIAM, ISTE, AMPI, etc. He is also acting a board member reviewer in 6 journals. He has published 52 international journal papers and 6 books. He has guided 21 MPhil scholars and 10 PhD scholars. He also did 30 talks on mathematics, 55 talks on spirituality, and 13 online workshops and 10 offline hands-on workshops with more than 1,000 members of participants. Sir, it is a great privilege and honor to have you among us. I now request Professor Dr. T. Venugopal to take up the session. Welcome, sir.
Yes, let me start presenting. Yes. Good morning. Very good morning. This is, hope I am audible. Yes, madam.
Yes, sir.
This is Professor Venugopal. I am Professor of Mathematics in the Department of Mathematics and Computer Science of Sri Sathya Sai University for Human Excellence, Gulbarga. This university offers free education at all levels, completely free education. So I am proud to be a member of that university. This is how you reach me. You can have a look at it. In case you want to get in touch with me on clarifications on this or to get materials on this talk, you can always get in touch with me. I am on WhatsApp and I have a YouTube channel, a Telegram channel. You can get in touch with me. Thank you. Now, at the outset, I thank the Department of Mathematics of Rajalakshmi Institute of Technology, Chennai, for having arranged this talk on modeling and solving queuing problems with the Microsoft Excel as part of a faculty development program on probability and queuing theory. On today, I have a disclaimer to make. This concept of operation research modeling, including this queuing theory modeling, linear programming modeling, whatever it is, through spreadsheets is found in certain books called management science books. And I'm only responsible for the flow and the customized examples. Example templates have been taken from mainly from the first book, Introduction to Management Science, a modeling and case studies approach with spreadsheets, 5th edition by Hillier and Hillier. One more book is also there. I will, if you want, I can send these 2 books to you. Okay. Then what about operation research? Just to have a look at it, this waiting line management is a part of operation research. And this operation research is a concept of decision making concept, essentially business decision making. Okay. And this waiting line is a part of that. Now, before getting into the waiting line, I would like to give an outline of problems that can be solved and modeled with Excel based operation research, not only this queuing theory. Just to have a look at it. It's like we can model finance models. The investment models can be attacked. production models, purchasing models, distribution model, scheduling models, decision making models, and transportation assignment inventory, and finally queuing models can also be attacked. So we will be touching this queuing model. There are various phases in operation research. The identification of the problem, formulation of the problem, constructing a model, selecting the appropriate input data, deriving the solution, testing the model and solution, establishing controls and implementation. We will not get into all this. What bothers us? What are all the processes in operation research? Allocation process is there to perform activities in an effective way. Inventory process is there to decide how much to order and when to order. Waiting line process is there to decide the number of servers for customers. This is the queuing line. This is going to be the topic of this particular webinar in the part of FDP. And one more process is there, replacement processes to decide when to replace aging facilities. Okay. And what is the waiting line process, queuing process? What do we need there? It can be applied to any, for example, any queuing model. Before getting into that, let me clarify. I will be using Microsoft Excel 2007, and however, you can use any version of Office, Open Office, and all that. I will be covering a little small, short exposure to modeling queuing line problems, using spreadsheets. Why do I stick to spreadsheets? There are other software which can be used to solve queuing line models. One thing is spreadsheets. If you use the open versions of OpenOffice and all, spreadsheets are free. Spreadsheets are free. You need not purchase anything. And even if you go for Microsoft Excel, it is licensed with your laptop or something. So you can make use of that spreadsheet. And this is very useful for students to get into this, and for staff also to generate various examples through when we try to do this. Okay. And what's the beauty of this doing through spreadsheets, through simulation, is that you can solve problems of bigger size. You can study the queuing models of bigger size. My expectation is have an inclination for to learn this concept, and maybe most of you are familiar with the spreadsheets. I am assuming that, and if you need further exercises, books, and the Excel sheets that I show now, I will be happy to send, because I am only illustrating. I am not, since I have only 1 hour time, I will be illustrating the problems on how this Excel sheets can be used to solve queuing problems, modeling and solving queuing problems. Let me very briefly tell you about waiting lines. Waiting lines involve, see, waiting lines you see everywhere, right from ration shop. Okay, your when we go to spa, when we go to saloon, when we go to railway booking counter and all that, you come across these waiting lines. Waiting line involves arrivals. Certain people arrive at the system, and there's a two sections are there in the waiting line in the system. One is the waiting line, and the other is the service. For example, when we go to this railway reservation counter, you might be seeing the seats wherein you just sit, okay, and that is the waiting line. Okay, that is the waiting line, and the service, the waiting line time is there, and the service is actual service. You book your tickets, and suppose if you go to fill fuel for your car, there may be space for only 3 or 4 cars in the station. The other cars will wait outside the station. Okay, they won't enter the system. So there are two things: waiting line, the waiting time in the waiting line, and waiting time in the system. Okay, so waiting time in the queue is that till you arrive at the counter, there's a waiting time. Okay, and once you are in the counter, once you are in the service, how much time does it take? How much time does it take? And the exit also. Okay, and where is the need to study these queues? Study these queues. For example, studying queues can throw light on the system. For example, my family doctor was there. He asked me a simple question, knowing that I am a max guy. He asked me a simple question. See, every day the patients come to me, and sometimes the patient enter my room and shout that see he was waiting for a long time, hmm, and it took in 3 to 4 hours for him to see me, and I happen to spend more times for on some patients, the other patients have to wait, and all that. So how to avoid these complaints? Can I improve this? He asked. So there is a way to do this. See, so suppose the doctor spends 15 minutes for a patient, okay, 15 minutes for a patient. That is also a queue. Okay, what can be done to improve the service quality in the waiting line? That is one issue, and related to the queuing issue. For example, you might see the television put over there and the magazines put in the queuing line, so as to people don't realize the waiting time in the queuing line. This is part of service operations management. This waiting line also comes part of service operations management, where how do you manage services? See, certain places the waiting in the queue is inevitable, cannot be avoided. Suppose you go to a hospital for a regular checkup, okay, regular master health checkup. There will be a big queue. There will be 30, 40 people sitting before you, and there is no way you will have to wait at certain counters. But when we know the waiting time, when we come to know the waiting time, we can design the service layout in such a way that people don't realize the waiting time. See, you enter a very big hospital, okay, multi-stored hospital. You will be seeing the hospital services are divided into various floors and various rooms like that. So it is not a single facility. You won't feel like sitting in a queue. They know that the waiting time is going to be more. So the studying the waiting line can help to improve the system, can help to improve the services. Okay, so that's why we study the waiting system. I was telling about the doctor. For example, the doctor spends 15 minutes on a patient. What can be done in the queue itself? Some nurse can check the blood pressure of the patient. Some nurse can check the sugar level of the patient. Somebody can check the pulse of the patient. And all that, when all that is finished, you might have seen in very big hospitals, somebody will take note of all your previous history, put a summary to the doctor, so that the waiting time with the doctor will be less. So studying the waiting line will certainly help to improve the services. It helps in the service operations management. So it is necessary to study queues. And certain formulas are always there. I will not get into the formula. I will tell you about the terms that we are going to use. See, there are two factors that are essentially will be used here: the arrival rate and the service rate. Those who are familiar with the queuing system will know this. For the benefit of others, I will tell about the arrival rate. Arrival rate depends on the inter-arrival time. For example, if you go to a bank, in a bank there is queue. There is queue, but you cannot say bank opens at maybe at 9:30 or something. You cannot say all the customers will come and wait there at 9:30. No, no. 9:30 people may not enter. Suddenly 9:45 4 people may enter, and 9:55 3 people may enter, and after a gap of even half an hour, a lot of people will enter. Okay, so this inter-arrival time, that is the gap between one arrival and the next arrival, is the inter-arrival time. Based on that, the arrival rate can be calculated. That is on an average 3 persons per minute, 4 persons per minute, like that. Then the service rate. The service rate is also not a fixed one. For example, if you go to a bank, when a customer steps in, he will come for various purposes. He may just come for an inquiry. He may come to fill up the entries in the passbook. He may come for to get the demand draft. He may come to get a loan and all that. Okay, so for everything, different service times will be there. Okay, for a DD it may take 10 minutes. So for a entry it may take just 1 minute. Hmm? To withdraw money it may take 3 minutes. You might have seen in many banks, citizen charter. The DD taking time 7 minutes like that. How do they arrive at those numbers? You might have seen in banks. Okay, the DD time 7 minutes, entry 3 minutes, and withdrawal money 4 minutes like that. They would have. How do they arrive at these numbers? They arrive at these numbers by studying the queue for over a period of time and also by simulation by simulation, by simulating the system, they will come to know what will be the waiting time. The certain numbers will be used LQ. LQ is the average number in the queue. Average number in the queue before entering the system. Okay. It is not just the arithmetic average. There's a formula for that. Using this lambda and mu. So for any system, the main thing will be to compute the lambda and mu. Then WQ is the average time in the queue, the average fellows in the queue. For example, I tell you, when you enter the what is that petrol system, petrol bunk, there is two kinds of queue will be there. So, for example, in the what is that in the shelter, maybe two or three cars can enter. Outside that many cars will be there in the queue, many bikes will be in the queue. Okay, even before getting into the server, there may be a small queue. Okay, then there are two things I told you: the system and the queue. Queue is the waiting time in the queue, that you join the queue and till the time you come to the server. Well, who is the server? Server is the person who either gives you the demand draft, the clerk, or the person who gives you the railway ticket, or the fellow who fills fuel for you, and all that is there. Okay. Let me put it silent. Then, and the time taken in the system is time taken in the queue as well as time taken to get service. Okay. Even I will be taking the case of a barber shop, a barber. Even for him, the service rates will differ. If a fellow comes just for trimming the hair, that will take one time. If fellow comes for a shaving, that will take one more time. If fellow comes for some facial, that will take more time. So like that, everywhere the service time also differs. So we will be basically calculating these numbers LQ, L, WQ, W, okay? And the number of servers can be single or multiple. For example, if you go to a petrol bunk, there will be multiple fellows ready to serve you. If you go to a bank, in certain small banks, there will be only one teller, and in bigger banks, there will be two or more tellers. How do they justify the introduction of two or more tellers after studying the queue only? After studying the queue only. See, just like that, the manager says, their head office, that see, the people are waiting for a long time. I want one more teller counter. Just like that, the head office won't provide them with another teller counter. They will study the queue. Okay. You see that maybe if a counter is there in a college, maybe students will come only during the break. Otherwise, there won't be any job over there. If you have two tellers, there won't be any job. Okay. So the necessity for multiple channels can also be found out by studying the queue. And these formulas are always there. We will be using them in Excel. Just have a look at it. The formulas for this mean time in the system, average waiting time in the service, and all. Now we will know about simulation. What is the need to simulate? What is the need to simulate? For example, a day, any particular day will be different from any other day. Any other day. For example, in a petrol bunk, maybe there will be lean days, and certain days people may not come on a holiday. There will be less flows. On weekdays, even during time, during peak hours, the thing will be more. The queues will be more. And take for example, I am taking the barber shop. In the barber shop, only during the morning, hours, and during Saturdays and Sundays there will be a lot of queue. Then how do you know the average waiting time? You have to simulate. You have to simulate. Simulation can be done in Excel. What is simulation? Simulation is observing the data for some period, maybe a week or for a month or for a year, depending on accuracy. Just approach it for many days. Then you compute certain probabilities. Okay, you come to know the average service time, the average arrival rate, and all that you compute. Then you simulate it for many more days to come, so that you get a clear idea of whether certain counter to be introduced, what will be the average waiting time, and this will certainly help to improve the system. Okay? If you always go to many shops, there you may have to wait. For example, if you go to a playing station, your children may have to wait. What they will do, they know that there will be queue outside the playing station. They will put some dolls and all that, so that the students, the children get distracted. So this computing simulation, it is not your animation; it's a simulation. Just have a look at it. These systems randomly generate the arrival and service rate. For example, there is a function in that I will be using primarily RAND, R-A-N-D, RAND. This will generate random numbers, and based on these random numbers, I will get to know the arrival and the service and the departure. For example, randomly, for example, I put like this. I Even if I do not have the Excel, what I will do to define randomness, I will have the die with me. Okay, I will just throw the die at 9:30. 9:30, I will throw the die. Two will come. Then I will say two customers enter. Okay. Then what do the two customers do? Again, I throw the dice once. First customer will take 5 minutes. Second customer, I roll the dice. Second customer will take 4 minutes, like that. So this randomness is ensured in Excel sheet also. We will soon get into the Excel sheet. Okay. For this is the computer simulation plays essentially the same role in many management science studies. Like you have heard about the mechanical simulation. Okay, this mechanical systems can be simulated in a smaller model. Like this, computer simulation also helps us to understand the system. I will just briefly tell about this. A coin flipping game. Maybe later. I will get into the queue first. And if I have time, yes, I am getting into a case study now. This case study has been, yes. Anything can I do? Yes. This case study is a queuing model case study. This has been taken from the book Introduction to Management Science, 5th edition by Hillier and Hillier. Here he takes the case of a German barber. Just to go through the para. Yes, this haircutter is a German barber. He runs a one-man barber shop, as usual. He opens a shop at 8 a.m. on each weekday morning. So we are considering only weekdays. His customers arrive randomly at an average rate of two customers per hour. So this is how do you get to this average rate of two customers per hour? You observe it for many weeks. Okay, observe it for many days. Then the customers per day, if maybe it's a 8-hour day, then divide by 8 and get the average number of customers. Okay, and he also has an estimate that he needs some 20 minutes for each haircut. So we are considering only the haircutting now. The other aspects I'm not touching now. We are taking the haircutting facility only as of now. His business has increased. More customers have started coming. Okay, and the problem is he's a single fellow, and more customers are coming because of his neatness in work and promptness in work. But regular customers can wait. Regular loyal customers, what they will do, so our own fellow, they will afford to wait. Or even if they go back, they will come back at a certain time. But the problem is with the new customers. The new customers, they come, they will see the crowd over there, they will see the waiting time, and they will go for the next shop. Probably that customer is gone forever. He would go somewhere. So he wants to know whether he can install one more assistant over there. One more assistant over there. This is not only the barber shops I have taken because it is given in the book. It is true for any bank trying to open one more teller counter, any petrol bunk which is trying to open more counters, okay, any railway reservation counter which is trying to include more reservation counters. If you go to central in Chennai, you will see many counters. If you go to Mambalam railway station, you will see one counter like that. Okay, so this has come in the journal. The loyal customers will tolerate an average of 20 minutes, while the new customers will tolerate only 10 minutes of average wait. So this is outcome of some article. With a longer waits, they typically take their business elsewhere in the future. Now, should the haircutter hire a new associate to share the workload? That's a question. But you see, why is it related to queuing? It is related to queuing because it is very much dependent on the queuing time and the service time. Depending on that only, we have to decide whether it is not about money. Maybe he can hire an associate only on Saturdays. He may hire an associate only on Sundays. But is there a need to hire associate? What is the input given? The loyal customers will wait for 10 minutes. The new customers may wait for only for 10 minutes. Okay. Loyal customers will wait for 20 minutes, and new customers may wait for only 10 minutes. So this is the input. Now, what are the probability distributions over here? I'm getting into the spreadsheet short in a while. Certain background working is there. The time required to give a haircut, say, varies from 15 to 25 minutes. He said 20 minutes. So we take 5 minutes here and 5 minutes that side. So equally likely, 15 to 20 minutes. Estimated service time is a uniform distribution. Let us decide the distributions. It's a uniform distribution for the interval from 15 to 20 minutes. I assume familiarity with the probability distributions. Now, to generate a random observation from the uniform distribution with values between A and B, equally likely is A plus B minus A. It's a random number. For a uniform distribution between 15 to 25 minutes, it is 15 plus 10 into random. Okay, we will be using this formula in the Excel sheet. The barber shop has random arrivals of customers averaging 2 per hour. So the estimated distribution of inter-arrival times is an exponential distribution with mean of 30 minutes. To generate the random observation from the exponential distribution is minus mean plus logarithm of random. For a mean of 30 minutes, minus 30 ln of random. These formulas I will be using. So any queuing system, before you study, decide whether which distribution it follows, whether it's Poisson or exponential or normal, the arrival and the service rate also. Both you should decide the probability distributions. Okay. Then the formulas come. Now building the building blocks of the simulation model here, description of components of the system, including how they are assumed to operate and interrelate. A simulation clock, what is that? Simulation clock runs over time. Then a definition of state in the system. What are all the states? Waiting state, service state. Okay. Then the method for randomly generating the events that occur over time. So we must randomly generate the entry and the service also, because entry is also random, service is also random, may take any time. Okay. A method, for example, any time, for example, a person with a lot of hair comes over there, it will take more time. A method for changing the state in the system whenever event occurs. So that means when the system will entertain the entry person and maybe to accommodate them in the sitting chairs and all that. So various states will be there, receiving state, and you will be waiting in some point. So it's the system will have finite states like the weighing machine. You go to the weighing machine, and that will be in a silent state. When you put a coin, it will go to weighing state, and all the different states will come. Okay. Now let me get into the sheet. This is the model sheet. I will go to the Excel sheet and show this. This is the computer simulation. What we enter there, what we find out. We find out the customer arrival. I will go to the Excel sheet also. I'm showing the screenshot now. Okay. We know the inter-arrival time. That is 30 minutes exponential. The blue ones are data. Second one, the minimum service time is 15 minutes, maximum service time 25 minutes. I can change these numbers always 30, 15, and 25. Then the average time in queue is computed. The average time in system is also computed. How do we compute them? Okay. So before that, these formulas, I think I made it clear. Just have a look at the formulas. Let's have a look, that is enough. The components are customers and the haircutter is the server. Simulation clock is just T, the simulator time that has elapsed so far. So at 8 o'clock, the simulation clock starts at 0 and it goes till the end of that day. Okay. Definition of the state in the system, what is that? Number of customers in the barber shop at any time T. That's what really matters. If there is nobody, there will be more persons. That's what really matters for the new customer. How many are inside? 4 are there, 3 are there. So that is the state of the system. Okay. Then we go to the formula, we generate and all this. Let me get into the Excel sheet and explain in the Excel sheet what happens in the time that remains for me. Then I would like to tell you about the preemptive queues and non-preemptive queues. What are these preemptive queues? Suppose you go to a temple. Okay, you go to a temple. We are all in a queue. Yes, we are all in a queue. A lot of persons there. Suddenly, a minister will arrive. What will happen? Yes? Yes, please mute your mics. I am hearing some noise of a child. Kindly mute your mics. If you have doubts, you can ask me. Otherwise, try to minimize the noise. Thank you. I was telling about the preemptive queue. Suppose you are waiting in a temple queue. Okay. Suddenly a minister or a VIP arrives. What will happen? They will not be in the queue. They will be taken off the queue and immediately they will enter the system. Okay. That is preemptive queue. Preemptive queue. In that, two possibilities are there. Okay. Suppose somebody will be having darshan inside. That somebody will be asked to go out and the VIP will enter there. So their service ends abruptly. But it cannot happen in a, maybe in a petrol bunk. In a petrol bunk, even if a VIP arrives, he may be asked to go to the front. But when somebody is filling the tank for somebody, some car, it cannot stop in the middle. So in the barber shop, even important person arrives, he will move ahead of the queue, but he cannot replace one who is being serviced. That after finishing service only this fellow can enter. Okay. So this, if I have time, I will discuss about the preemptive queues and the non-preemptive queues. Now, let me describe the system. Have here, I have named the cells. How do I name the cells? See, I have named it, see here, I have named it as mean inter-arrival time. How do I name a cell? Come to, for example, this G2. It is named as G2. You see here, it is named as G2. If I want to name it as maybe RIT, if I put RIT, Rajalakshmi Institute of Technology, enter RIT and press enter. So this cell will be G1. You see in the name of the cell, this is G1. But if you come to G2, it is named as RIT. So you can name the cells. You can name the cells. That is what I have put here. The average time in line is in D10. Average time in system is in D11. Inter-arrival time is between C16 to C115. How do you get this list? See, you can name the cells there. for your convenience to make people understand. But if you go to data, not data, formula, yes, formula, go to formula and define names option is there. Okay. Below that you have use in formula. Yes, use in formula. Paste names option is there. If you click that, whatever names you have defined over there will be listed like this. Okay. That comes when you model. I can explain when we do it as a workshop. Now, let me come to the sheet. How do I frame the sheet? You see that the sheet has customer arrival. Okay, customer arrival. I am naming them as 1, 2, 3, 4. They come in. And the inter arrival time is random. What is that inter arrival time? The gap between one customer and the next customer. The gap between arrival of one customer and arrival of next customer, it can vary, it can random, it can be just random. It can take 5 minutes, it can take 1 hour, it can take 2 hours, like that. Okay. So inter arrival time we are calculating. How do we calculate? Just look at the formula there. It is mean arrival time. What's the mean arrival time? Mean arrival time is what we have entered there. Mean arrival time is inter-arrival time, mean inter-arrival time 30 minutes. Okay. So based on that, this will automatically generate. What is that? Look at the formula in the formula bar. Shall I make it bigger for you? I will copy and make it bigger for you somewhere. I will copy it here. Copy the formula. Wait, I want to show a bigger version of the formula to you. You see that that is changing automatically. I am copying the formula to show you to this way. Yes, it's not magnifying. I will restart it again. I am restarting the Excel sheet. One minute. Yes. I'm restarting the Excel sheet. Just wait. Yes. It has loaded. I tried to change the formula. It closed. Now have a look at the formula. It is ln rand. What is that rand number? See, this rand is somewhere. If I put this, maybe the next sheet I will illustrate. If I put equal to, any formula in Excel starts with equal to RAND. Okay, this RAND with the two, one open and closed bracket. will generate a random number. Just have a look at it. I will magnify it now. I am magnifying it. Just have a look at it. See, and it will change. If I enter somewhere some number, it will change. See that the random number is changing. Okay? That's what I am refreshing the page. That's what I am doing. This RAND changes. Or I can always put there rand between. That also one option is there. It is like random between a bottom and top. If I say random between 10 and 20, it will generate a random number between 10 and 20. So why do I use this random number? Let me come to the sheet and explain you. So in the inter-arrival time, what's the inter-arrival time? When does the first customer arrive? Okay. He arrives at 8.4 minutes. Okay. So if I refresh this page again, that means if I enter change, you see that inter-arrival time changes here. So first customer arrives only at 40.4. That's the inter-arrival time. The time of arrival is 40.4. Now, and when does the service begin? She is the first customer. So as and when he arrives, the service begins at 40.4. What is the service time? Service time is also random. Look at the formulas here. Service time is minimum service time, that is 15 minutes, plus maximum service time minus minimum service time into that random. That randomness can be anything. Okay? It can be a small number or big number. So for this person, the service time is 18.4. So service ends at 58.7. Time in the waiting line, nothing, because he is the first customer. And the time in the system is 18.4. Okay. Now let me come to the next inter-arrival time. It is also randomly generated to be 4.9. So the gap is 4.9. So when does the second customer arrives? He arrives at 45.3. Okay. Then the service begins at 58.7 because the previous service ends only at 58.7. Okay. And the average service time, the service time is also taken as random. Service time can be anything between the minimum service and the maximum service following the uniform distribution. So the service time is 21.3 and the service ends at 80.3 because for this service begins 58.7 plus 21.3 gives me 80. So service, the time taken in the line is 13.7. Time taken the system is time taken in the line plus service time. It is 34.7. So like that it goes on, and you see that I can simulate it up to, and now I have simulated up to 100 customers. I can just drag the system like anything. So I have simulated up to 100 customers very quickly. I can drag it further also. I can drag it for 200, 300 customers also. You see here, as an you see, just carefully watch the first interval time. It is 40.4. It is random. Let me refresh the page. Refreshing the page, I enter some number or delete something. You see that inter-arrival time has changed to 5.4. Let me refresh it again. Just carefully watch. Inter-arrival time is 24.3. That means I am repeating one experiment of 100 customers a number of times. So a number of times. So each time this will change. You have a look at the average, this WQ and W. Just to have a look at it, this will keep changing. Now the average time in line is 15. Average time in the system is 35. So 15 plus 20, 35. Now let me refresh the page again. To refresh the page, what do you do? You just enter some number or delete some number. Just watch the box, the colored box. It will change now. See? So it is for next experiment, it gives that the average time in Q is the 10.3 minutes and average time in the system is 30 minutes. Okay? Let me do the experiment again. That's what the beauty of simulation is this. Change it. Now for the new system, 22 minutes in the line and 42 minutes in the system. Let me do it once more. It is 27.2 minutes in the line and 47 minutes in the system. So by this, you can repeatedly repeat the system so that you come to understand what is the average time taken. Let me get back to the presentation now. See, now this evaluation of the number of customers over the first 100 minutes. This is what happening. Number of customers is increasing. The elapsed time, it varies like this. It is a uniform distribution, it varies like this. Now simulating the barber shop with an associate. Now we will simulate the system with the two servers. What is the difference? The only difference is waiting time in queue is always there, but there are two servers. When haircutter completes the haircut, a customer can enter, or when the associate completes a haircut, an arrival can happen. So two servers are there. The formulas will differ. That's all. Model will be same. Now the financial factors also we should analyze here. What's the revenue per haircut? What is the tip per haircut? Maybe somebody may give tips. And the cost of maintaining the shop, the salary of the associate, that is also there, because you cannot just go for the new associate ignoring the salary. So we should take into consideration all this before studying the system. So in addition to his salary and commission, the associate would keep his own tips. That is another problem. Otherwise, the revenue will go to the haircutter. The tip of every customer would come to the haircutter. But when a new associate is introduced, no doubt the waiting time will decrease, but the tips will go to the associate. So shop is open from 8 to 5. Okay, admits customers for 9 hours. Now look at the following formula. The current distribution and the simulation says an average of 18 customers per working day. That's what I get throughout the day. Only 18 customers. Not that he takes only 20 minutes, so per hour 3 fellows will come, for 9 hours, so 27 fellows will come, not like that. Average, he gets only 18 customers. That we see from the simulation. How do you simulate? You involve a random function and then simulate it repeatedly so that you get different ideas, different numbers. Now the net daily income is $256. Now I will have a queuing simulator that I will show you. I will show you a queuing simulator after this presentation. It can run computer simulations for various kinds of basic queuing systems. Okay? You can any number of servers up to a maximum of 25. 25 servers you can manage for the model that is built in that book. Then you decide about the any one of the distribution: exponential, uniform, translated exponential, constant time distribution, Erlang distribution. Any one you can take over there. Okay? And these are all the things that we compute in that queuing simulator. These are templates provided in the book. This can be very well used for classroom demonstration, and can be given to the student, and you can give a real-time problem so that you can use the template and give you the answers. We will calculate this L, LQ, W, WQ. Okay? Yes, this is the queuing simulator. I will show the sheet shortly. Number of servers, I can enter there 1, 2 or something. Then inter-arrival time, I can select the distribution, exponential or mean, I can enter over there. Okay? Exponential distribution or Erlang distribution, I can enter, and accordingly the formula will be there in the sheet. Then service time, it follows certain distribution, uniform distribution or something like that. That you will decide only after seeing the data. Suppose you see, if you see the curve to be bell shaped, you always say it is a normal distribution. So like that you can guess the distribution along with the data. Now how many simulations you want to run? I say 10,000 simulations. I will run the simulation and show you. It will calculate so many answers. Then now that queuing model, I get back to the haircutter model. Maybe another, I will close in 10 minutes. The haircutter model, you see the mean, if the mean inter-arrival time is 20, then the point estimate of WQ is 3.33 minutes. So the adding an associate will reduce the average waiting time before a haircut begins to less than 10 minutes. So why the 10 minutes? It is observed that a new customer will wait only for 10 minutes. He won't wait beyond 10 minutes. So adding a customer will ensure, adding an associate will ensure more customers, right? So gradually you can attract more customers. That is the conclusion. Now, the queuing simulator can be done with an associate, without an associate. So if you run with an associate, number of servers two, number of servers two. So you can see the average L is 2, LQ is nothing, W is 30, only 30 minutes in the system. Waiting time in the system is just 30. The average waiting fellows in the queue is almost zero, almost one, almost one. There is not much thing over there. So if you, without an associate, it will be like this. Without an associate, single server, and the time taken over there is in the system is 40.5 minutes. You see here 40.5 minutes. And with an associate, I will show both the models in the Excel sheet. With an associate, you can guess it to be 30 minutes per system. So let me show certain sheets for you. Some more sheets for you, some more templates. I will send them to you. Okay. Now, let me, where is the simulation problems? Yes. All right, yes. I will show you some queues now. This PLT template for queuing simulation that I will show you. Okay. See, I should enable the macro. This is written with the macro. That this comes with the book. Now have a look at it. Okay. This is the simulator. This is the simulator. Means if you run the simulation once, it will vary. The randomness will vary. For initially you see number of servers, I have put it as 1 there. This blue ones we can change. Blue ones we can change. Okay. And you know that in Excel sheet you can generate the drop down menu. Do you know that? In Excel sheet, if you enable the security features over there, you can enable a drop down menu also. So a drop down menu is coming in this template. You can constant, airline, exponential, uniform, all that can be chosen. And the mean arrival will automatically be put there depending on that. And the distribution, service time distribution can also be selected. Okay. Yeah, the beauty you should know is in the Excel sheet, you can develop the drop down menu. That is very, very easy. You should have a certain methodology to do that. Okay. Now let me run the simulation once. Okay. Just watch. So when I ran it once, what happens there? This 1.3333 is there for L. W is 40.333 is there. So 40 minutes in the system and 1 minute in the line. 1 minute in the line. And the average length of queue is not just one, not even one, not even one. Okay. Now you see that it keeps changing. I will run the simulation once more. See here, it's 41. W is 41. And the LQ is point, that is not changing. That is not changing. You can take all these entries and find the average. Let us see the average. Now it is 41. Let me run the simulation once more. It is 42. You see that waiting time in the system is 42. Let me run once more. It is 40. Once more 41. Then 40. Then 40. Then 38. It goes down a bit. I run the simulation once more. To run the simulation, you must have written a macro. That is written there, and I can pass this template to you so that you can work on it also. Now, let me run the, you see that the waiting time is average 38 to 40. So 40 is there. 40 is there. Now, let me change the number of servers as 2. Okay. Now, with only one barber, it is taking 40 minutes in the system. Let me change it to 2. And run the simulation again. You see that the weight, the W becomes 21. W becomes 21. The entire time in the system becomes only 21. 21. That means half the time. So you should see the after even you can see after seeing this simulation, you can guess whether introducing the associate is beneficial to the barber or not. It certainly saves time. but at the same time, it enables new customers. It gives more money to him, despite the fact that the associate takes away the tips and the associate takes away salary. Now let me try one more. Let me put, for example, 3. Let me change it to the 3. Run the simulation again. See that it is only 17. 17. Only 17 minutes, 20 minutes, 20 minutes it takes. Let me change it to 4. Run the simulation. See, 20. It keeps changing. So if I change it to 1, see what happens? It gives me 1.3. L is 1.3, W is 40. But when you put it as 2, what happens? 20. So let me put it as 3, whether it improves. Let me see. I want 3 associates. Still 20 only. No much improvement. So if I put it as 4, no much improvement. Only 20. So I conclude that while one associate is necessary, more than one associate is not necessary for this particular system. I will show you certain other templates also. I can send it to you for each model. For MD1 model, there is a template. Okay, you'll be knowing about these all queuing models. For MD1 queuing model, the book gives a template, and ME1 queuing model, it gives another template. Okay, templates are there for various models, various queuing models. One more model, MMS model. MMS model. See the MMS model. I can generate. See, I can utilize the beauty of Excel in generating bar charts also. Okay. So here lambda mu I am putting, number of servers also will change. It is yes as 1, 2, 3, something like that. Okay. So this is a template. So the book of management science gives various templates of preemptive priorities and empty priorities also. I was telling you about this. Preemptive, what's a preemptive priority? I said that there are different types of queues are there. It can be empty or preemptive. The various queue properties are there, like VIP can be taken ahead of the queue. If it happens, what will be the waiting time? If more VIPs come, but how will it affect the queuing time for everybody? So, for example, if a prime minister arrives at the temple, and you will have to wait for 2 to 3 hours, that's gone. Okay? So, how the priority affects the queuing system, that can also be studied. So, all these models are given in the book which I showed you. What is the book I showed you? One book. This book I can send it to you if you need it. The management science, a modeling and case studies approach with spreadsheets by Hillier and Hillier. This book, in fact, describes the entire operation research paper by the means of spreadsheets, without any need to work it on the paper. Okay. In particular, the queuing model, these templates help the teacher to understand, help the student to understand the problem more, and it helps the teacher to give more problems, and it helps both to develop queuing models. For instance, this model is then developed for barber shop. It can be developed for a bank. It can be developed for a railway booking counter. Okay, and such things can be developed. So using this template, many such things can be developed. I stop my presentation here, and maybe if you have any queries, I can answer. I can share this PPT, I can share the Excel sheets, templates, and hoping that this will motivate you to go through that book, to try to make this queuing models, automated process, learning easy. By hand, you cannot simulate it for more than 1 or 2 items, but here you can simulate the model for a number of days, a number of hours, number of customers, so that the queuing system is studied in a better way. Thank you. Yes. Yes, madam, you can take over. Kanchana, madam, can take over.
Yes, sir. Yes, sir.
Yes.
Participants, any questions?
Any queries? If it is there, I can address. Related to giving theory or related to operation research? I have given a number of talks on operation research using spreadsheets and solver. Yes.
No queries? No
Uh,
questions?
no queries. You can wind up.
Okay, sir.
Yes.
Okay. So I'll give you the vote of thanks.
Yes.
Ladies and gentlemen, a very good afternoon to one and all present here. It gives immense pleasure to deliver the vote of thanks for this event. First of all, I would like to propose my heartfelt thanks to Professor Dr. T. Venugopal for an excellent presentation. You made an excellent presentation and making today's session a very meaningful and interesting, sir. All the participants are inspired by your highly sparkling words. There is no doubt that the seeds you sow today will reach our students as delicious fruits. Thank you very much, sir. I would like to express our sincere thanks to Honorable Chairman and respected Vice Chairman for their support. I would also like to thank our beloved principal, faculty members, head of the department, and participants for making this event as a grand success. Once again, I thank everyone. Thank you, sir. Participants, the feedback link will be posted in your chat box as well as your mail.
Yes, madam. Thank you. I will be
Thank you,
posting the
sir.
presentation